Hello, good morning, good afternoon, good evening, everybody. My name is Gary Russell. I have been a contributor committed to Spring Integration for about 2.5 years now and have been full-time on the team since the beginning of this year. Today's talk is going to be about, okay, we all have these great Spring Integration applications. How do we figure out what's going on inside those applications? I'd like to start out by just pointing out that this is not an introduction to Spring Integration. It is sort of a little bit more advanced. I point you here to some other webinars. Mark Fisher did one a year or so ago on message-driven architecture with Spring, which covers some of these capabilities and Spring Integration in particular. And then Oleg Zurikowski, another core committer on Spring Integration, did a couple more webinars recently. These practical tips and tricks. Now, this particular webinar will be made available as Amy said, but I'll also give you a link to the project that we're working on. It is going to be available in the Spring Integration samples. We're going to talk a little bit about STS templates, how to create some Spring Integration projects using Spring Source Tool Suite. We'll look at JMX and exposing the internals of a Spring Integration with JMX, and we'll also look at Spring Insight and the new Spring Integration plugin for Insight, which enables us to look at traces for applications running in a Spring Integration environment in TC Server. First of all, I'd just like to point out that the project that we're using for this session is based on one that's created via the Spring Integration templates that are now available in STS. For those not familiar with this capability, you can do in STS a new Spring template project, and when you bring up the dialog box here, you see there are now 3 options for creating Spring Integration projects. There is a simple file polling project. There's an even simpler project, standalone, and both of these are just run from a main. And then we have this war project, which is essentially a little bit more complex, runs inside of a war, an app server, and the application polls Twitter and presents the results, as you can see here, on a web page. So the last 10 tweets based on some search criteria. So as I said, this project that we're going to use and we're going to add to today is based on that war project. So if you want to work through it, you can do it that way. Or as I said, this code is available currently in my repo, which I'll give you a link to, but it will be folded into the standard Spring Integration samples in the next week or so. Let's take a quick look at the state of this application context, as it's pretty much the start point. And in fact, in the GitHub repo, you can even roll back, check out back to this starting point if you actually want to work through it from time. So let's see what we have here. And first of all, I'm going to just show that we have a Twitter inbound channel adapter that simply is connected to a service activator, and all that service activator does is keep the tweets in memory so that they can be rendered on the page. And as we saw, the page is simply, you get the little avatar for the person who did the tweet, and it just polls the Twitter every 30 seconds. So we can see the configuration here. It's polling Twitter every 30 seconds and sending them to this Twitter service. It's just, and this is a good reason to go look at the integration graph, where we can just see visually what this application does. So we have our Twitter inbound adapter. It's connected to a Twitter channel. This happens to be wiretapped to a publish-subscribe channel, and then that goes to a logging channel, so we can log the tweets, so we actually see them showing up here at the bottom in the console. And also, just for the purposes of demonstration, we'll see this when we look at the mbeans, I'm bridging that pub/sub channel to a simple queue channel where those tweets are going to accumulate. So we'll be able to see how we're going to use JMX to perhaps monitor what's going on in in the application. You can also see on here there's a control bus, and we'll be talking about that and how to use the control bus to manage our Spring integration components using JMX or by sending messages to the control bus. So first thing we want to do, well, how do we? So we obviously we got a number of tweets here. They showed up. How do we know how this application is performing? How do we know what's going on inside of the application? The first thing we want to do is actually enable JMX. And Spring integration comes with an MBN exporter that is specifically designed to export the components of a Spring integration application, such as message sources, channels, and message handlers. So the first thing we need to do is declare an MBN server, just using standard Spring context namespace. And now I'm going to add the MBN exporter, the Spring integration specific MBN exporter, and that's under the JMX namespace. So you need to add the Spring integration JMX project to your POM, and that makes that namespace available in your application context. So I'm going to add I'm going to give it an ID. I'm going to call it integration MBN exporter. And I'm actually going to put these MBNs in a domain. I'm just going to put them in a domain called Spring application. Spring application. So that's all I've done. I just added the MBN server, added the MBN export. I'm going to save the file, and we just have to wait a little while for the context to refresh in the application. But while that's happening, I'll just take a quick spin over to Visual VM. Some of you may be familiar with Visual VM, some may be using JConsole, but essentially they're the same. They provide the same capability to get access to MBNs. The first thing for those who haven't used Visual VM before is you don't get MBNs by default out of the box. So you have to go to the Plugins tab here, and on the available plugins you'll find the MBN. You'll see here I've installed it here. The Visual VM MBNs is available from the available plugins. Once you've enabled that plugin, restart the Visual VM, and you'll be able to get access to the MBNs via that. So let's open up this particular application that's running now, and let's just take a look at what we got by just adding those two lines to our application context. You see here the Spring application context is the Spring application is the domain of our MBNs, and we have exported now channels, message handlers, message source, and each of these elements has a set of attributes. So we can actually look at the message source. It says whether it's running or not, and whether the how many messages we've actually received from this particular endpoint. There are operations. There are lifecycle operations. We can start, stop. As we'll talk about in a little while, that's a good way to have. You could use your enterprise management system, interact with these MBNs to actually control these elements at runtime. Going over to the channel, so we have this Twitter channel, which is the initial channel that we're sending the messages to from the adapter. And again, we have a whole bunch of good statistics here. What was the longest time it took to send, etc. Send durations, send counts. Now, there's not a whole lot going on here. If I refresh this, we're not going to see that. And this particular Twitter feed, we're searching on hashtag Spring integration, not unsurprisingly. But so we picked up the last 12 tweets, and if anybody did add some more, then we would see them being added. So that's in the essence useful just in its own right. We're just going to expose all these attributes as MBNs. One thing I'll point out, if we go back to the STS, the integration graph, as I mentioned, I'm also dumping these tweets via the wiretap, as well as logging them. I'm just dumping them into a queue. So back in the Visual VM, if you see this channel, which I call queue, one of the attributes on a queue channel is the current queue size. So we can use that attribute to detect if there's some kind of a blockage in the system, or some, you could maybe have your management system look at that attribute, and if it goes above some threshold, you could raise an alarm of some kind. See, there seems to be a bit of a lag on the video, at least from my perspective here. Okay, so that's pretty much it from an MBean perspective. However, the integration MBean exporter itself doesn't export itself. The integration MBean exporter that's made available via adding the int.jmx MBean export line is it also has some useful information on it. So let's see. Well, how can we export that itself? Well, simply enough, that MBean is exported using the standard Spring MBean exporter. So we just add the standard context MBean export element, and again, I'm going to put it in the same domain of Spring application. And I'll save that. And while that's refreshing, so you can see now all I added was context MBean export. I added the MBeans that's going to export into the same domain. Now, this particular application, as you saw from there, is not particularly interesting, and there's not a lot of moving parts at this point because we're searching on the Spring integration hashtag, and there haven't been any tweets apart from those 12 that we've seen lately. So for the purposes of this demonstration, I'm going to add a second channel adapter. Now, let me show you what I'm going to do. So I've built this class, a dummy Twitter, that's going to generate this dummy tweet at some rate, and what I'm going to do is add an inbound channel adapter that's going to poll this class and effectively simulate tweets occurring in real time. So in order to do that, I just need to add an inbound channel adapter. I'm going to call it, let's see here, dummy Twitter. It's going to put its data into the same input channel equals Twitter channel. The method that we're going to call, if you remember from that class, is just called getTweet. And I'm just going to put an anonymous inner bean. What's going on with this namespace? Just love it when that happens. Let's see. Oh, to do it's not input channel. Brain freeze there. It's just channel, of course, for an inbound channel adapter. So it's going to poll this getTweet method on the dummy Twitter class, and I just need to create this bean. I'm not getting code completion here. And of course, I need a polar. And let's do it at a fixed delay of 5 seconds. Let's see what happened here. Okay, let's just wait for the context to reload here. Let me just... I'm going to clean out the app. Just republish the app, and then we should be good to go. While we're waiting for TC Server to start up, I'm going to just take us back now and see what the integration graph looks like. And as you can see now, we have both the main inbound channel adapter feeding the Twitter channel, as well as this dummy Twitter channel. So we should now be able to see some activity going on in the in Visual VM. Because this is going to be polled, this dummy channel is going to be polled every 5 seconds. So we're effectively going to get a tweet every 5 seconds. Let's see. Okay. Since I restarted Tomcat, open a new. Must have mistyped the Spring. Anyway, so when I added the other Ambient exporter, we can now see we have the integration Ambient exporter is now exposed. And it has some additional information, like now you notice here it has a queued message count. So that's messages that are queued throughout the entire application context. So that again is something you could have your management enterprise management software monitor that. But we also have a number of operations, things like get all the active channels or get all the channel names. And as we'll talk about in a little later, and this is a new 2.2 feature. We released Milestone 2 a couple of weeks ago, and Milestone 3 should be out shortly. But this is actually in 2.2, the Milestone 2. We have this ability to stop our Spring application context in an orderly fashion. That's one of the things we've been asked several times on forums is, well, how do I shut down a Spring integration application cleanly? And this now gives us that capability, and we'll look at that in a minute. So let me go back to here. We're now running. We have our dummy Twitter feed is giving us a new tweet every 5 seconds here. So if we go back over to Visual VM and we actually go look at these message channels, so if we look at Twitter channel now, look at the attributes on it, we can see the count is incrementing. So another thing that's valuable to do from a monitoring perspective is you could actually check whether these counts are moving. So your enterprise management software, most of them have the ability to add rules and say, well, if I don't see any activity in a particular channel, then maybe that's also some indication that something's gone wrong. So as I said, we'll get back to the ability to use this graceful shutdown component in 2.2 to bring down our application. But before we do that, I just want to touch on one more thing with regards to JMX that maybe not everybody is familiar with. So now we've instrumented Spring integration by simply adding these three lines to our context. We added a server. We've used the integration MBean exporter to export MBeans representing the endpoints and channels within our integration context, and we also, using the standard Spring MBean exporter, we can actually export our the integration MBean exporter itself. Now, one of the things you might then ask is, well, what about my components? So we can see here that this Twitter adapter is invoking via the Twitter channel. It's invoking this Twitter service activator, which in effect invokes this Spring Bean called Twitter service. So let's just go take a look at that service and say, well, what if I want to instrument this class and get some additional information out of this class? So this particular class does maintain a number of tweets that it's received, and really all we have to do to expose this is to make this a managed resource. I've previously already instrumented the getter for that local tweets method here as a managed metric. Now, a managed metric it's similar to managed attribute, but it's specifically for it's a different type of managed attribute that integrates with Hyperic. But in essence, really all you have to do is add managed attributes, managed operations, and expose your MBean as your object as an MBean by just simply adding this @managed resource. So if we go back over to our Visual VM, we now see we actually have this default Twitter service is exposed as an MBean, and sure enough, the attribute, this total tweets attribute, is part of that. Okay, so it's all that's all fine, and we can manage our beans. We can start them, stop them, our endpoints using JMX. But what if we want to do it programmatically? Well, of course we can use programmatic techniques to interact with JMX if we want to. We can have a JMX client and invoke with the MBean server. But Spring integration also provides a control bus element. So if we go back, if you remember, I showed that on the diagram. We've added a control bus channel and control bus element, which is simply defined like this. We have a channel called control bus channel, and it is wired into the control bus. If we go back to the Twitter service, we've auto-wired the, and again, this is all done by that template. It wires in the control bus channel as a message channel, and then to actually interact with our beans, we can simply send messages to the control bus. So here, the general syntax is @ and then bean name and then some operation on the bean name. Now, you remember when we looked in Visual VM, we had start and stop operations. So this particular method in this service starts and stops the adapter. And I've added some code to say if we've also got this dummy Twitter adapter in there, then let's go send a control bus message to that. The web page that shows these tweets, and you can see now this is full of those dummy tweets because it's been running for a while. We've got these buttons on here to start and stop Twitter searches. So we can hit stop, and sure, in the console down here, you can see that we stopped both adapters, and now you'll see that we're no longer getting those tweets coming in every 5 seconds from that dummy Twitter adapter. And we can restart, and away we go. So basically, we can control our endpoints, particularly the active ones. We can start them, stop them. We can introspect them to get statistics, all using JMX, and we can interact with them using the MBean. using the control bus. And another method that's there is running. So you can also send a control bus message via a gateway that returns a Boolean type, and you can invoke any method on that bean. So an is running will return back a true or a false. So you can actually dynamically determine the state of your elements using those capabilities. And the next thing I want to take a look at is Spring Insight. The TC server that comes with recent versions of STS comes bundled with a new plugin to support Spring integration flows. Previously, Spring Insight was great for introspecting or looking at web traces, or what happened to this web transaction, where's the time being spent, but we couldn't look at Spring integration flows. The Spring Insight plugin for Spring integration now provides the capabilities to do that. So let's just first of all take a look. So when you open the property page for the TC server instance that comes bundled, the developer edition that comes bundled with STS, down here on the Insight tab, I'll warn you that by default, gathering of metrics is not enabled by default. So you have to check this to re-enable it, save the setting, and restart integration. But you restart TC server. But you can see here that the Spring integration plugin is now provided bundled with recent versions of STS. It's the plugin itself is available on GitHub, but like I said, it's now bundled with the recent versions. So once you've enabled Insight, we want to go take a look at what it actually gives us through Spring Insight. But before we do that, I actually want to make this application a little bit more interesting, because it's not really doing very much. It's getting a tweet and calling a service activator. So what I want to do is add a couple of components here. First thing I'm going to do is add a header enricher, pretty common component. Let's call it ID equals add foo header. Its input channel is Twitter channel, and its output channel is Twitter 2 channel. I'm going to call Twitter channel 2. And all I'm going to do in this is just add. I'm going to add a correlation ID to this message. Let's see. I'm just going to add foo to the correlation ID. Next thing I'm going to do is add a transformer. Now its input channel is going to be Twitter channel 2. And its output channel will be Twitter channel 3. And of course, I got to change my service activator now to take its input from Twitter channel 3. Now, one of the things that people who are not familiar with using the Spring integration graph view is, even if you're not using it to build your integration flow, it's useful to do a cross check to see, did I wire everything up the way I expected. We do get a lot of issues on bulletin on the forums where people have got some issues, and a lot of times it's mistyped channel names or channel A's wired to the wrong component. So it's always a good sanity check to just bring up the Spring integration graph view for in STS. And now we can see again we have our two input channels, and now our flow looks like it's right. We have this foo header, we have our transformer, and it's wired up to the service activator. So before I actually move on, I'm actually going to do something in the transformer. Let me just call it ID equals. I'm going to call it no up. I'm not really going to do anything in this transformer, but I'm going to call it no up but slow transformer. So what's that mean? Well, I'm really not going to do anything to the payload. I'm just going to add a little bit of Groovy. I'm just going to put a delay in here so that we can actually see something in Insight. I'm going to wait for a second. And then I'm just simply going to return the payload itself. So I'm not actually really transforming. It's not really a transformer. It's not doing anything, but it's just really as an illustration of what's going on. So I'm going to save that. What's the error here? Oh, value equals foo. Restart. So once again, just look while TC server's restarting, our graph, we have Twitter channel, add foo header. Oh. Aha! Now I found a. Okay, Twitter channel 3. It's just it's just the way it's organized. The diagram here. I can always fix that by moving these guys around. So. There we go. So let's go back, and hopefully the application context is initializing here. Okay, here we go. While it's actually starting, we can just take another look at the Ambient server, and we should see that we now have message sources. We now have 2 message sources. We have these the dummy Twitter source, message handler. We've now got our no op but slow transformer. We can see the Twitter service activator, of course, and of course the add foo header. So each of these components is now added in. The message channels, we can now see all the additional message channels were added, and looks like things are running. Whoops. Okay. So let me. So our application is back up and running. So now, Spring Insight. Let's go take a look at Spring Insight. This is running in a war, is running in TC server, and Spring Insight gives us the ability to introspect what's happening with our application. So first thing I'm going to look at is, and for those of you that aren't familiar with Spring Insight, it's, as I said, bundled with the TC Server Developer Edition. It's also available in the Standard Edition. And you see here we have our application called Monitoring. And there are a number of endpoints. Now, endpoint in Spring Insight is slightly different from Spring Integration. Endpoint in Spring Insight is where would a flow start. So we can see here we have things like home controller home. So we can see when I clicked on the home page, these are all the calls to that over history, and we can drill down and look at what actually happens inside of that. For those of you not familiar with Insight, this is a standard use of Spring Insight to introspect, to look at what happened in a flow. So we can see here we did a get on the monitoring URL, and we can see how where the time was spent in terms of rendering the view, etc. But what we're here to talk about is now the ability to look at Spring integration flows, because they're completely asynchronous tasks that are running inside of the war, but we are able to capture performance information. So we'll see here that the endpoint is really the Twitter channel. So because it's a polling channel adapter, that's not the adapter itself isn't part of the flow. Really it's the channel. It's the start of the message being sent to the channel. And you can see here that it doesn't look too good. Most of these events are pretty darn slow, right? Because the default thing with Insight is this 800 millisecond delay. But let's take a look at one of these flows, and we can pick some of these examples and see where the time is being spent now in our Spring integration flow. So I picked an element here, but it looks like I have a. Let me go to a recent one. Okay, this is more like it. I just happened to pick up an old one from before I added those additional elements. So here we have this is based on the direct channel parent Twitter channel, right? So the elements get named in the Insight flow in the same way that they're named within the application context. So as we can look down the flow, direct channel Twitter channel, of course we have that wiretap, which goes to this logger channel, which sends it to the logging adapter, and we also bridge it to that queue channel. That's not particularly interesting. The main flow goes from the Twitter channel to the transformer, the add foo header enricher, which is under the skin is actually a transformer. It then goes to Twitter channel 2. It then goes to the no up but slow transformer, and then from Twitter channel 3 to the service activator. And now we're actually going to invoke the method, the add on Twitter messages. But we can see from here, where is the time being spent? The whole thing took 3,005 milliseconds. Looks like we got a second in the no up but slow transformer, and a couple of seconds in the Twitter service to add the message. Now that's weird. You know, why is that the case? Why are we seeing that? But this gives you great insight. No, pun. Please excuse the pun. Great insight into what's going on in your integration flow. You can see exactly where the time's being spent. And then you can drill down and investigate why. So we know why this took a second, because I added that thread sleep 1000 in that little Groovy script that's in the no up but slow transformer. But I wonder what's happening in this. Where's this 2 seconds? Because we know that all that class is doing is storing the data in memory. So let's just dig in and do a dummy investigative thing into what's going on. So let's look Twitter service, and the method was add Twitter, and lo and behold, yes. So all I did was I added some code here to say if this is the dummy tweet that's coming from the Spring integration flow, then from the dummy adapter, then just put this dummy sleep in there. So Insight. Again, it's not particularly complex application. There's just a couple of transformers and a service activator. But you can imagine that if you have a deep or a complex flow, you'll be able to look at this and figure out where the time is being spent. Okay, let us talk about the control bus again. And you'll notice, as I said, we have the start and stop. I'm going to try and time this to see if I can cause an exception here when this. Yes. So I hit the stop as soon as I got a tweet. Now we know that we had a thread.sleep for 1000. Right. So if we stop an inbound adapter that's got an active message in process, we're going to interrupt that thread, which may not be what is really wanted. So with Spring Integration 2.2, we've introduced a graceful shutdown capability that enables you to do an orderly shutdown of your application context. It goes through a series of events and I'm going to try and time it so that I'm going to hit it right after I get a message, and I'm going to maximize this page, and we'll see what happens. So you see here it said stopping the scheduler, and now it's stopping the message store, stopping the Twitter. So it stopped everything in an orderly fashion. It waited for any in-flight transactions to complete before we ended up with before we terminated the inbound adapter. Whereas when I hit the stop on the adapter directly, it just canceled all threads, or attempted to. Obviously, if they're not interruptible, it's not going to interrupt. But if it's doing anything that's interruptible, it's going to interrupt it unless you use that graceful shutdown. That is available in 2.2 milestone 2. We still have some more work to do that. There are still some areas where it's a little bit tricky. Like for example, the plain TCP inbound gateway, for example. When you stop that, it closes the socket. Well, that's not great. What we really want to do is stop new incoming requests, but let any running requests go out. So we still have some work to do on that, and that's going to be a sort of moving target. So as we get feedback on this capability, we'll add some more capabilities. Okay, the next thing I want to show very quickly is message history. Now, one thing I should point out is that once you've stopped the Spring integration flow using the orderly shutdown, you can't restart it again. It's really intended for an orderly shutdown before you restart the JVM. As far as message history is concerned, I'm going to just change the log level to debug, and I'm also going to add the message history capture so that we can see what that does for us. I'm going to stop TC server at this point because we stopped the application context, so we're going to have to restart it anyway. So I'm just going to add the all we have to do is add the message history element to the application context, and we'll start to capture message history. Now, while that's starting up, I just want to bring up a basic point about debug logging. We do get a lot of or a fair number of questions on the forum where maybe elements are not wired together correctly, or something is happening that the user can't figure out what's going on. As I mentioned earlier, using the Spring integration graph is a great way to double check that your wiring is as expected. But another big capability, and regardless of message history is interesting, particularly in complex flows, because you'll be able to see where that message has been. But for simpler flows, in any case, just turning on debug logging, we find that turning on debug logging is often all you need. You can trace messages through the system. You always see these pre-send, post-send messages on channels, and you can very quickly, generally, see what's going on in your application. So this is starting up now, and we should start getting some logs. And as we can see here, let's see. Let's wait for. Okay, I'm going to stop so that we can actually look at one of these logs. Let's see. So here, let's take this. Oh, here we go. Pre-send on Twitter channel 3. So we know Twitter channel 3 now is our input channel to the service activator. So if we scroll along, when we're just turning on debug logging, we've got a payload which is a tweet. And here we have the history. So we can see what has happened with this message since it hit the system. So it came from the Twitter adapter. It went to the Twitter channel. It went to the add foo header component, Twitter channel 2, no up but slow transformer, and then Twitter channel 3. And of course the correlation ID is what I put in there. But there's the history. So message history is a very useful capability if you have a complex flow and you want to figure out where a message, how a message flowed through the system. But as I said, just having debug logging turned on is also very useful when you're trying to figure out what's going on in your flow. So we've talked about JMX. We export our integration MBN exporter exports all of our Spring integration components for us. You get lots of statistics on channels, performance and stuff. And we can actually export the MBN exporter itself using the standard context MBN export. That, of course, also will pick up any app managed resource annotated classes, so you can include your own beans in the class and in the Visual VM. That's why I had different. I have a space at the end here. That's why it wasn't there. Now, what I would like to do to wrap up is there was a question came up on the forum. I think it was last week. Is somebody said, well, using standard stats is all fine. I'm probably not going to be able to go into full detail on this here, but I'm going to point you to it. It is in the sample code. But the question was, well, it's all very well, but what if I want to measure performance based on the payload type? Well, one thing you could do is you could basically have a payload type router and then send the appropriate messages through a series of through different channels and then bring them back together again. But that that might work, or you might want to add some more sophistication. So again, I'm not going to go into detail here because we don't really have time. But in this code, and you'll see it on GitHub, I created this payload-aware timing interceptor, and really all this does is capture statistics for messages going through the channel, and then effectively timing them based on their on their payload type. And so to add that to the flow here, we already, if we scroll down to the to here, we already have an interceptor, the wiretap interceptor on the Twitter channel. So I'm just going to add another interceptor here. The class is that payload aware. What did I call it? Timing. There we go. And it actually needs it needs a constructor argument, which is an array of classes that we actually want to capture. Any classes that are not declared in this array are assigned to the object class. So I'm going to do Java lang string, or I'll spell Java right in a minute. And then I'm also going to capture for the tweet object. Just going to get the package for that. Oops. So just going to add that as another. Tweet. as I said, this is in the project. So when you run the project in its current state from GitHub, which I'll show you a link in a minute, it will do this. If we have time, I'll start it up. And while this is starting, I'm going to go to the links page, show you those links, and then I'll come back to here to see make sure that if this is up in time, I'll do that. Otherwise, we'll go to Q&A. So let me just, while that's starting up, let me go to back to the slide deck here, and I'll read your questions in a minute. But essentially, there are these links. www.springintegration.org is the homepage for the project. The second link there is for my GitHub repo, and you see the Spring Integration samples. It's in my webinar branch on that, and this project is in the monitoring. Is it called monitoring within the intermediate project? The project is out there right now in my repo. Over the next week or so, we will make this a permanent project within the Spring samples, the main Spring Source repo. And then, of course, the link at the bottom is for forums. If we don't get to all your questions in the time we have left, then please go ahead and post your questions up on forum.springsource.org. This is a full link to the Spring integration, but if you just go to forum.springsource.org and scroll down and just click on the integration link, and it'll take you to the forum. Again, springintegration.org is the main page for the project. Let's see back to here, and so we are up. So let's go to Visual VM again, and the new interceptor is exposed as an MBean called Payload Aware Timing Interceptor, and I just added a simple operation to here to do a get summary. So we can do a get summary here. If I expand this, as you can see, we have had we have statistics here based on class. So we obviously we're only sending tweets through here, but you can see here how you can use this technique to very easily intercept the channel at whatever point you want. In this case, I intercepted it right at the start of the application, so we can get timing of the flow based on the application class. So you get statistics based on that class. Again, it's not a fully fledged. I wouldn't say it's particularly sophisticated, but it should give you some techniques to where you can take the standard facilities that we have in Spring Integration and enhance them using interceptors or other MBeans to provide additional management and monitoring information. So with that, I'm going to switch back to see if I can handle some of your questions. Okay, first question is, does Spring provide any tool to secure access to the MBean's operations? This is a standard mechanism to using. We connect to the MBean server using whatever technique you've used to expose it. By default, TC Server only exposes the server on the local host adapter, so you can't hook to it remotely, but you can control that. You can also enable SSL connectivity that requires authentication against the MBean server. That's just standard JMS. There's nothing special about that. It's just standard JMX. Question: can we use our own object naming strategy for the MBeans? Basically, what I like to do is show the message handler types under Spring Application Integration Message Handler. There is some capability of doing that via the domain name. You can also inject a MBean. I don't remember the name of the class, but it's probably not available through the namespace. But if you declare the integration MBean exporter as a regular bean, there are properties on that where you can inject a naming strategy to name the bean. So it's not It's not 100% flexible, but there is some flexibility there. Whether you can get exactly what you're looking for, I'm not sure. But if you want to post that question to the forum, I can take a look at that for you. Assign, is there any performance impact? Question, is there any performance impact due to these metric collections? Would they run in the same thread as the message processing, or would they run in a separate thread? Yes, the way that Spring Integration instruments, or the Spring Integration MB Exporter instruments the endpoints and channels is by adding an interceptor, an AOP interceptor. So there is a small hit in terms of capturing the statistics, but it's typically not measurable when compared to what the application itself is doing. There is definitely a small hit. So a lot of people might decide to make that enabling the MBeans to be perhaps controlled by a profile under Spring 3.1, so you can control whether it's on or not. Could you please show an example of using a control bus to change a routing channel resolution, if that's possible? Yes, it's possible, but I don't have time to show it now. There are methods on the recipient list router where you can actually add and remove routes from the router. If you have a custom router, then whatever you expose. But yes, there is capability of using the control bus to do that. And I guess somebody's just saying that the payload timing interceptor is a good starting point. What is the typical running environment for deploying Spring Integration applications? That's not really a management thing, but that's just a standard, decision whether you're going to run in an app server or not. A lot of people like running in an app server, even though they're not web-based, because the ops people are familiar with it, and also gives you a lot of the management tools can auto-detect them. Ethereal JVMs that come up and come down are a little bit more difficult to manage. Question, can Insight be deployed in non-TC server containers? It's a TC server specific product or capability. I don't believe it can be run in other containers. Question about using Spring Integration with TIBCO RV. I'm not familiar with what TIBCO RV is. Certainly, if TIBCO JMS, it's used extensively with TIBCO JMS, but I'm not sure what RV is. If there are no further questions, thank you again for attending. It's our pleasure to bring these to you. And as I mentioned, if your question didn't get answered, or you have additional questions after this, then please go ahead and go to the forum. The example application is in my GitHub repo, and as I mentioned, we will be moving it in the next week or so into the standard Spring Integration samples.